Back, guys, and this is our last video, I think, probably for the probability. Okay, the last one is normal distribution. Why we call it normal, or why we call this type of curve as normal distribution? It's essentially because it happens most of the case. Let's just imaginary. If we consider this one is our wealth and this is our probability. So for the really rich person or rich people, they are only at here, so they only contribute a little bit. And for the really poor people, they contribute slight. Also, the probability is quite small. And for most of us, just lies in between this region. Okay, and same thing apply for your VCE things. Most of students will be within this region, and this one you can consider as 50. Okay, full marks and perfect mark, perfect score, and for this one you can consider as 0. So not, of course, it's really hard to get 0 for VCA, right? Because you're gonna take SAC and at least you're gonna get some marks. So it happens a lot. So that's why we tell you guys this one is called normal. And for the normal distribution, we don't need to really remember the rule for this one, but you do need to remember is how to convert the normal distribution to the standard normal. Okay. So for the normal distribution, two things are really important. The first one is the mean, and the second one is the standard deviation. Okay, I will explain it later. So for this one graph, the mean is basically decide where your normal distribution is, so the location, to the left or to the right. And the standard deviation, sigma, they basically decide if it's become like spread or if like more condensed. Okay, so the or we call like the steepness of the curve is determined by the sigma value. Okay, so this just gives you the taste of the normal distribution. So the next one is standardization for the normal distribution. So that's why we make the mean is mu and our sigma is standard deviation. So the region between this is 68%, and the region between this mu plus minus 2 standard deviation will be 95 percentage. Okay, 95%. That's why we always see this one in the continuous random variable as well as in the discrete. It's because it's normal, and normal can approximate their probability, and we will discuss this one later. Okay, and the mean from 3 standard deviation, the probability will be 99.7%. So what does that mean? Let's say, for example, 2. It simply means if I did IQ test, and I think this is kind of represent for the whole people. If I got mean is 100 and standard deviation is 15, so I randomly ask a person and he did the test. So there will be 68%. His score lies between 85 to 115, and 95%. His score will lie between 70 to 130, and 99.7% probability his score will lie between 55 to 145. Okay, that's the meaning of 68% and 95% and 99.7%. Okay, and another thing is, if we know 95% of score IQ is between 70 and 130, what percentage of the score are more than 2 standard deviation above or below? Okay, so for each of the group, they are just like share equally, like 2.5%. So overall, it's just like 5%. Okay, and another thing is standardized value, and the formula is this one. So why we need standard value? Because sometimes, for example, you study two subjects, math method and specialist math. So imaginary your math method got 80% and your special math only got 70%. But we cannot easily say that your math method is better than your special, only depend on score. So what we do is we convert them into standardized score. We compare with the ranking. So how many people are behind you, or uh, what percentage you are at in your school? Essentially the ranking. So sometimes it might be you are the top one for the special math, so rest of the class just got 60%, and but you are not really good at math method. Maybe like the medium score for that one is just like exactly 80. So you just like the middle of the math method, but the top for the special. So mark cannot really say anything. Again, its ranking is important, or how many people is may get the score is lower than you. Okay, this one is also applied for your ATA score. It's just like ranking. So essentially means if everyone else is only can get 0 and you get 1 mark, so you will be the perfect score 50. Okay, so for if you got positive z value, it means it represents lies above the mean, and if you got negative, which means you are lower than the mean. Okay, so this one is 16b. And for 16c, it's just like determine the normal probability. Just remember, if you want probabilities in continuous, you always use CDF. Okay, in both cases, just normal CDF to get the answers. Okay, and just one more thing to emphasize here is this one, they gives us the distribution, sorry, the probabilities. They want us to find the C1 and C2. This one you must use inverse normal. But the area, just make sure if you choose the left, you have to, using the inverse normal faculty of your calculator, enter 0.05. Okay, instead of 0.5, because it's in the middle area, it's 0.95. So again, if you want to find the C2, you have to enter 0.75. Sorry, 0.975. Okay, this is essential for us to be clarified over here. You have to make sure you know how to enter the value and find the C1 and C2. So another important one is symmetry properties. Basically, for normal distribution, they are symmetric about the mean. Okay, and if you want to find the probability is greater than A, it's essentially means you want to find the probability Z is less than negative A. Okay, they have the same area. This one is also important, and it can be tested in the exam 1, because they kind of ask you to find equivalent expression for anything like probability x or z greater than 3 is equivalent to probability z less than negative 3. Okay, so 16d is ask you to solve problem using normal distribution. Again, you just need to type in the cast to get the probabilities, and sometimes using the symmetry with means to get the values. Okay, and for the last part, as I mentioned earlier, my normal can approximate my other distribution, but in high school we learn two types of special probabilities, like normal distribution and binomial distribution. That's why if our n is increasing, we can look at the graph. Our binomial graph is approaching like normal or like the bell shape. So for rule of thumb here, we make sure our NP and N times 1 minus P must be greater than 5. Okay, must be greater than 5, then it's satisfied the approximation. So example 9, if you look at this one, if without normal approximation, we have to use binomial really slowly to get the value. But if we use normal, we find mean and standard deviation, we can directly get it easily. Okay, and you will find out both probability are quite close to each other, which means it's really good approximation because my n times p is 300 greater than 5, n times 1 minus p also is a really big number, I think. So it's again, it's 700, so it's again, it's much greater than 5. That's why this approximation works. Okay, so essentially for this one, make sure you know how to change to standardized score and compare them. And to emphasize here is make sure you know how to use CAS as well. And another point here is symmetry properties for normal distribution. Okay, and I hope this video is helpful for you understanding the normal distribution. And if you think my video is useful, please click the like button and subscribe. And I see you guys for the next videos. Bye bye.